Fluid power is everywhere.
Fluid power is not new technology. Fluid power has been around for a while.
The majority of people have no idea what fluid power is influencing.
The limits for fluid power are still not defined.
There's no other technology that even comes close in terms of power density.
For a mechanical engineer, fluid power is a great place to be. The things that were impossible just a few years ago are now possible.
It's energy storage.
It's like a really powerful muscle. If you just step outside and take a look, you're pretty sure that everything you see out there has had some fluid power applied to it.
And on top of that, the cherry on the cake is digitization of hydraulics. That is the unexpected.
You get kind of this sort of visceral thrill of feeling when you get to see this really big arm go whoom.
Fluid Power, a force for change, is a co-production of the National Fluid Power Association and TPT's Minnesota channel. Support for this program has been provided by the following organizations.
いう感じなんですけれども、大きな力で高応答高精度の過信ができるところが油圧の最大の魅力だと思っています。
Because you're dealing with such sort of high forces in small packages, you have to know how to basically harness that properly. So it's important to study these things, to know exactly how to make these things do what you'd want them to do and no more.
If you would have asked me a year ago what was fluid power, I would have been like a lot of other people and been like, it's in your brakes. And that was like my extent of fluid power knowledge.
I really thought that it would just be truck brakes. And when I started finding out that it was heart pumps, when I started realizing that the only reason why an airplane flies is hydraulics, the only reason why somebody lives through a surgery is because of the pneumatics in the respirator or the heart pump, then I started to realize, wow, there's something really profound here.
I have found these to be very, very intellectually rich, very sophisticated devices that one really needs to understand and bring to bear some pretty high-powered analytical tools to allow you to really exploit the full range of their capability.
You can touch it, you can feel it, you can see it. Fluid power is on the human scale.
It's nice when you actually have this physical system that you get to play with and you know, sandpaper down and you're, taking bladders and pushing them up and down to try to see if you can work a short stroke cylinder, and that intrigues me.
The pump is the heart of the system, basically. It's attached to the engine, and there is energy conversion happening with the pump. The pump sends the flow typically to the brain of the system. The brain of the system is the valve. And from the valve, it's directed to actuators. Those actuators could be motors, could be cylinders.
It's very important because it's able to pack a really big wallop in a very small package.
So this small hydraulic motor right here has about the same power as this large electric motor over here. So what we can see here is that fluid power has a much higher power density than electric power.
Many things are driven by hydraulics. It's just kind of an unknown that it's really there, and really that's a testament to hydraulics then, is because if nobody really recognizes it, it's probably doing the job efficiently.
It's not just industrialized applications. We can find them at Disney World. You can find them at IMAX theaters. It touches every aspect of our lives. You find it in automotive applications, in aerospace applications, and then industrial applications just provide that enormous diversity.
Some examples of fluid power that we might encounter every day would include construction equipment that you see when they're building roads or building bridges. All of those bobcats and backhoes use fluid power to give the motion and the force that they need to move the dirt or the road equipment around.
There are many examples of fluid power in every car. Our shock absorbers are fluidic systems. Those little cylinders that hold up the hatchback when you open it, those are pneumatic fluid power systems.
And so when I describe pneumatics to people, they don't know what it is. I say, next time you're next to a bus and you hear that psh, everyone says, oh, that's a pneumatic brake.
You know, your chairs in the office, every time you lower down the lever, that's pneumatics.
On a golf course, fluid power is used on almost every machine that cuts grass out there. The propel or the traction drive is hydraulic, the steering is hydraulic, to lift the cutting units is hydraulic, and to drive the reels are hydraulic to spin them. What hydraulics, the advantage of hydraulics has to solving your solutions is you have so much flexibility in where you place your components. Mechanical system, you need drive shafts, belts. You need to keep your areas open to allow you to get there. With hydraulics, you just have to send a hose or a hard line out there to the wheel motor or a reel motor, whatever. It allows a lot of flexibility in your design when you use fluid power. So you get a better appearance out on the golf course with it.
We use fluid power to generate the forces and motions in a lot of the systems that test products. These products are tested really to make our world safer.
So if you drive a car, you hit a pothole, you want to make sure that the wheel doesn't fly off or the shocks can take the load. So we use fluid power in that case to design machines that can recreate these shocks, the potholes. When you're doing a swerving maneuver, we make these machines that at their core is basically a hydraulic actuator. And we use that to apply loads, apply stresses that you might see in a car as you're driving it normally, and so you can make sure your design is optimum and it's safe.
We also make earthquake simulators, which can generate humongous forces and motions that would simulate the power of an earthquake, but on a smaller scale where you can control it in a testing laboratory.
そういった非試験体の破壊のメカニズムを解明したり、強度を確認したりする装置です。その装置には大きい力で高精度が要求されますので、油圧の技術を使っております。
What we do is we build a giant table and we support it by a number of hydraulic actuators. And these hydraulic actuators can shake this table in all 6 degrees of freedom, all 3 translations and all 3 rotations. And so we can fully simulate the actual motions of an earthquake. So our customers for these systems are generally researchers that are trying to design better ways to build buildings and towers and bridges so they'll be more earthquake resistant.
Fluid power is not new technology. Fluid power has been around for a while. The thing that it's changing the world now is its application.
It's energy storage. It is service life, extended service life. It's low mechanical wear. And on top of that, the cherry on the cake is digitization of hydraulics. That is the unexpected. It's here. The whole industry has embraced it, and it has elevated our value proposition to completely new heights.
Anywhere that you can take old technology and and make it better and put it to a new application, I think would excite any engineer.
Really what we call mechatronics is a really important trend, which is taking what people think is your grandfather's pneumatics or hydraulics and adding in a lot of electronics, and then on top of that, control theory.
So it's opening up a lot of avenues, and I think it's also stretching people's minds because as the technology continues to evolve, you're starting to think about the problems you're facing every day a little differently.
The things that were impossible just a few years ago because computer chips and software was not advanced enough are now possible, and applying that into fluid power is really making fluid power jump ahead in a lot of areas.
The productivities are increasing, and the comfort, the ease of use and the comfort for the operator is increasing. It's getting to be a lot of benefits for the end customers. Today, we can find fluid power in all kinds of surprising places.
Fluid power more and more is being used in art to help bring an artist's vision for the future to our sensibilities and to our present. There's an art museum in Milwaukee, Wisconsin, where the National Fluid Power Association is headquartered that uses hydraulic technology to reshape the outside of the building in interesting ways. And there's probably no other technology that could have achieved that without fluid power. The medical application is another big area that's changing in terms of fluid power. There's research going on right now to build fluid power assisted artificial limbs, legs or arms or hands that can move based on fluid power principles at the command of their owner, and really opening up a whole new window to individuals, amputees or others, who have those kinds of disabilities.
We hear a lot about robotic surgery, and you hear a lot about new advances in cardiology. A lot of what's going on is driven by fluid power. In, say, an eye surgery machine, the little thing that cuts at the end is pneumatically driven. They cannot use electronics, and that's making advanced surgeries to correct vision, cataract surgery, LASIK, all that's made possible actually by pneumatics, not electronics.
Think about the energy crisis that the world is facing right now. There is a huge demand for primary energies, whether it's oil, gas, or biomass, wind energy, solar energy, or ocean energy. And when I think about hydraulics, it touches every one of these applications. Hydraulics is used for oil exploration, oil production, for exploration and mining of coal, natural gas, wind power. We see the windmills out there. Hydraulics is hidden in the windmill. People don't normally recognize that hydraulics actually controls the blade of some of these windmills. Solar energy is another very attractive renewable energy application. Ocean power, where you harness the motion of the ocean waves on the surface of the ocean. You take that energy, you store it. You use that energy to create electricity, for instance. Unbelievable applications with imagination is your limit.
You have the ability to harness and store energy in a hydraulic or pneumatic system that you don't have in other kinds of technologies.
In the transportation area, we believe that fluid power has a lot of potential for as a powertrain for hybrid vehicles.
You have heard about the electric hybrid, Toyota Prius and others, where the idea is to use brake energy to store it in a battery and then to use it for acceleration. Now in fluid power, we have a counterpart to that, which I strongly believe, can do much better than the electric hybrid, hydraulic hybrid.
So this is one of the areas where fluid power, the fact that it's very compact, very high density energy storage, really lends itself to rapid energy capture and rapid energy redeployment in energy savings. When you brake a vehicle, you can take the energy of the kinetic energy of your vehicle, dump it into an hydraulic accumulator, store that energy, and then immediately have it available to dump it back into a hydraulic motor and re-accelerate the vehicle.
There are hydraulic hybrid vehicles that are either on the market or near on the market, but these are for very heavy vehicles, large vehicles. One of the challenges that we are facing is the fact that in order to store the energy, we need to have very large accumulators.
Over time, we see this as the technology matures, trending into lighter and lighter vehicles, and certainly we hope someday is in most of the passenger cars we drive, saving in some cases potentially up to half of the fuel we use.
How do we get the technology in fluid power to the point where we can start to compete with the age-old technology of hydromechanical transmissions, automatic and manual transmissions on passenger cars? Some people would look at that as the holy grail, because not only is the opportunity from a volume and revenue perspective tremendous, but it would be an opportunity for fluid power to start touching the average person at a point that now when they're in their garage working on their machine, they'll pull the hood up and they'll see fluid power in there.
The limits for fluid power are still not defined. It still keeps improving. Everything is constantly changing, and I think that's exciting. That's what makes it interesting and what is going to lead technology to lead our world into new places.
Fluid power is very interesting. From a technical perspective, fluid power is one industry that brings together for a mechanical engineer, basic training in materials, machine design, fluid engineering, heat transfer, thermal analysis. Almost every discipline that you come up through engineering and you're trained in is applied in the fluid power industry, and oftentimes within the same design team. So if you're the kind of person that really enjoys using all of the skills and maybe not so focused on becoming expert in a very tight niche area, fluid power is a great place to be.
If you want to be an engineer, obviously you went into it for some reason. I mean, maybe it's because you're good in math and science in high school and your counselor said, okay, go be an engineer. But if you actually got an engineer because when you're a kid, you actually like putting together stuff with your hands, you actually like building models and Lego and whatever it is they got, the kids these days, Kid Connects or whatever, and you like seeing stuff move around, well, you get kind of this sort of visceral thrill of feeling when you get to see this really big arm go and it's very, very exciting. Again, I can't really put it any other way than to say it's cool to see big stuff move fast. It's just cool.
The things that are really going to play a big factor in the success of an engineer are things like creativity and curiosity.
I was the kid that when I was 6 years old, I took apart all of my toys and wanted to see how they went together. In 5th grade, when we had our science fair, my friends were writing reports on the Pomeranian puppy, and I was looking at how grandfather clocks worked and how the gearing on them controlled time or was able to report out time. So I guess just naturally I had kind of an inquisitiveness into how mechanical things worked, and that led me to kind of follow that through school and through college and then to end up working here.
The most rewarding thing is, in terms of working with industry, is to see ideas that I come up with get adopted and used, because it means that something that started off in the deep, dark recesses of my mind actually had some type of practical benefit.
Well, I've started and sold a few companies, and they've all been high-tech. And I was actually in finance, an investment banker, focusing on high technology. And I came across a few little companies that were in fluid power and thought, oh, that's my grandfather's technology. That's completely irrelevant. That's old news. And the more and more I looked, the more and more I saw that there were some neat opportunities that were being overlooked that were very high tech. And there was a real opportunity for somebody to come in and inject some new innovation, some new technology, bring a lot of this high-tech computer and control theory into the sector. And I looked at how big it was, the sector, and how much was actually going on. And that whole idea that it's going out of business or it's irrelevant is just not true.
When we talk about that new technology and new opportunities, that means growth for a business that leads to opportunity for people. And I think it's creating that image that this is not a stagnant industry. It's very vibrant, and we want more and need more talent in order to continue to grow.
We need more engineers, certainly, and engineers who know how to apply fluid power, how to develop fluid power to the next stage, and how to integrate fluid power with other disciplines. For example, how to integrate fluid power with electronics, controls, artificial intelligence, and so on.
The industry is really hungry for having the kind of talent, young, smart, hardworking, curious talent that will change the industry and change its image from something that's of the 20th century to something of the 21st century.
And all over the world, Europe, here in US, we have a problem of not enough engineers. We need engineers, and we have to attract young generation to engineering. And we have to explain why that is so important and why fluid power might be a platform to start and work in, because it's tackling all industry segments. So it's a chance for somebody to move and build a career on that, and saying, today I start in aerospace, but I can be tomorrow in biotech, because this technology is needed there as well.
There are jobs in fluid power that people just don't know exist.
This industry is just phenomenal opportunities, and it is exciting. How can you not be excited when you see all of this happening around us, and when you see hydraulics be such an important and fundamental part of our lives?
We need different jobs in the future. If you have higher automation, you need a complete different workforce on your manufacturing floor. We need people who understand the technology on the production floor and is able to run an automated plant. And we don't have enough educated workforce for that.
There's a very, very clear need, an unmet need, in terms of sort of computer-based intelligence being applied to these very, very brawny, high-power devices.
One of the things is to get those new and young engineers, those people that are interested in technology, more exposure to hydraulics. I'm a mechanical engineer by college, and I had a half a class in hydraulics, and it was more of a cursory level class. Well, what I wasn't aware of, and what wasn't made maybe as clear as it should have been, is all those dynamic control classes and classes that you may just think are generals really have direct application in hydraulics.
Not all the problems are solved in fluid power. It's not only the continual drive to smaller products, more power-dense products, better efficiency. It's also, there's just some pure fundamental understanding of fluid power that is still untapped.
I think what we'll look for in the future is new ideas coming into it as we get more and more people, as more and more research discoveries are made, and as more of those discoveries are translated into the classroom, will excite a whole new generation of engineers and technically minded students in this technology, and that will open up a lot of possibilities for us as well.
We're working with new materials, we're working with new fluids, we're working with new ways to control these fluids, we're working with digital controller technology that's getting faster and faster every day. Where is this going to take us in applications of fluid power? I don't know. We're working with applications today that we wouldn't have dreamed up 5 years ago. 5 years from now, again, it's going to be things we wouldn't have even conceived of today. It's very exciting.
So the future for today, as we look forward, is still wide open for technically interested people who are motivated by charging down paths that have not been completed all the way yet.
We have to spread the word, how important this technology is, as well as what kind of difference this technology can do to our future and give to our future.
Fluid Power, A Force for Change, is a co-production of the National Fluid Power Association and TPT's Minnesota channel. Support for this program has been provided by the following organizations: